Two of the major protocols we discussed earlier in this module were TCP and UDP. Remember that they live at the transport layer, and that's if we're talking about the OSI model or the DoD model, also known as the TCP/IP stack. And these two protocols, TCP and UDP, they're largely used to carry the data for our applications, whether we're doing email, we're surfing the web securely, maybe going to our bank, or if we're doing online gaming. We're probably using either TCP or UDP. But here's a question. Let's say that this client with an IP address of 10.1.1.1 is trying to communicate with this web server with an IP address of 172.16.1.2. And it's a web server, and we typically use HTTP when connecting to a web server, or HTTPS if we're securely connecting to that web server. But let's say that this web server is also an FTP server. It's also a telnet server. It might have multiple services. The question is, if I send a packet from this client over to this web server, how does the web server know to go to the web services on that server as opposed to the FTP or the telnet services on that server? Well, these applications that we use are generally associated with a port number. In fact, there's quite a collection of what are called well-known port numbers. A well-known port number is in the range of 1023 or less. And if we're going to a web server using HTTP, it has a well-known port number of 80. But we also have port numbers that are not necessarily well-known. Those are in the range of 1024 and greater. And when we're setting up a session between this client and the web server, we're actually going to use both types of port numbers. Check this out. Let's say that I send a packet from the client over to the web server. I want to go to the web services portion of that web server. Well, the source IP address is the client's IP address, 10.1.1.1. The destination IP address is the web server's IP address, 172.16.1.2. But check out the ports. The source port, in other words, the client's port, it's a number greater than 1023. It's one of those ephemeral port numbers. It's 1248. Now, the destination port, as we're going to the web server, that's a well-known port number. That's the well-known port number for HTTP, and the packet goes to the web server, and that web server knows based on that port number that this packet is destined for the web services running on that web server. Well, let's say that I'm going out to the web server and I'm saying, give me this web page. When the web page comes back, these numbers get transposed. If we were to examine a packet coming from the web server going back to the client, notice the source and destination IP addresses, they're flipped, they're transposed. And now the source port number coming from the web server is 80, and the destination port number is the port number of that client, 1248. And I mentioned that this traffic is going to be carried by either TCP or UDP. Sometimes it could be either one, but for web services, for HTTP, this is going to be a TCP segment. And the way this is stated is we say that we're using a TCP port 80 to go to the web server. And that's just one example, but we have many well-known port numbers out there. And this is not a comprehensive listing, but this is a listing of some of the more popular protocols with which I would want you to be comfortable. Notice on this table, I've listed a protocol, its description, and what TCP or UDP port or ports it might be using. And notice that DNS could use either one. It could use either TCP or UDP. But let's get an overview of these protocols, many of which you're going to see throughout your networking career. First up is FTP, File Transfer Protocol. If you're trying to transfer files across a network, FTP has been a great way to do that for many years. For example, as I'm writing a book and I'm uploading a chapter to my publisher, they have an FTP server, and I'll log into the FTP server with my username and password credentials, and I'm able to copy this chapter, this Microsoft Word document from my computer up to their FTP server, and they can have an editor go through it and mark it up, and I can pull it back down from that FTP server. That's the way that we exchange files. One drawback, though, to FTP is that even though I do have to authenticate, I have to provide username and password credentials, it's not technically a secure protocol. In other words, the packets are not encrypted. Secure Shell, SSH, that is a secure protocol, and we often use that when we're connecting to something like a router or a switch, something that we're managing on the network. Or it could be a server that we access via Secure Shell, and you see that it uses TCP port 22. By the way, notice that FTP uses a couple of ports, 20 and 21. Secure FTP or SFTP, it's going to give us that FTP file transfer service while giving us the security, the encryption provided by SSH. And that's similar to SCP, Secure Copy, which is also going to allow us to do file transfer, but it gives us some bonus information. For example, information about the file's original date and time when it was created. We don't get that with Secure FTP. And we mentioned that if we're connecting into a terminal session on a router, a switch, maybe a server, we could use Secure Shell to get us a secure connection. Well, another way of getting that console session, that command line interface, or the CLI, is to use something called Telnet at TCP port 23. However, it's not secure. The best practice recommendation is to not use Telnet if Secure Shell is available. Next, we see SMTP, Simple Mail Transfer Protocol, at TCP port 25. We commonly use SMTP to send mail from our smartphone, from our computer, to the mail server, but we can use other protocols to retrieve our mail from that server. We'll be talking about a couple of those protocols coming up. And here we see DNS again. We talked about that in the previous video. We said that DNS allowed us to remember names instead of IP addresses of destinations out on the internet. We talked about file transfer using FTP. We said, although it didn't do encryption, we did have to provide a username and password to authenticate ourselves with that server. Well, TFTP, Trivial File Transfer Protocol, is a way that we can transfer files with a server, and typically it does not require any authentication. No user credentials are required. We might want to use that within a controlled environment for security purposes. DHCP is another very common protocol. That stands for Dynamic Host Configuration Protocol, and that can be used when a computer or a smartphone boots up on the network and it needs to get an IP address. It can request an IP address from a DHCP server, and the DHCP server can say, all right, here is your IP address along with some other information such as here is your subnet mask, here is your default gateway, and there are other parameters that could be provided by a DHCP server. A protocol that we've already talked about is HTTP, Hypertext Transfer Protocol. That's commonly used when you're surfing the web and you're going to a web server. POP3, Post Office Protocol 3, that will allow us to retrieve email from an email server. We mentioned that we could send mail using SMTP. We could retrieve mail using POP3. However, there's another protocol coming up, IMAP4, that we probably want to use today instead of POP3. One of the drawbacks of POP3 is that if you have multiple devices that are accessing the same mailbox, maybe you've got a laptop, you've got a desktop computer, you've got your smartphone, and they're all pointing to this email server and you're using POP3, what oftentimes happens is you read your mail maybe on your laptop. And when you do that, when you open up the mail client on your laptop, it retrieves that mail from the mail server, it brings it down to your laptop, and it removes it from the server. Then you go to your desktop computer or you go to your smartphone and you say, where's that message? Where's that email I saw earlier today? It's not there because POP3 has downloaded it to the laptop in our example, and it removed it from the email server. And POP3 uses TCP port 110. NNTP, Network News Transport Protocol. It's not very popular these days, but it used to be popular for reading articles on Usenet news servers. The protocol that is very popular today is NTP, Network Time Protocol. This can allow our network devices to synchronize their internal clocks with a network time protocol server. It's a great thing if your network devices agree on what time it is. That can help us with troubleshooting as one example. If everybody agrees on what time it is, we can look at logs and say, well, this happened at 12:05 a.m. on this device, and something happened at 12:05 a.m. on this other device. I wonder if they're related. We can do some event correlation. And notice that NTP uses port 123, but it's a UDP port. Same thing with SNTP, Simple Network Time Protocol. It also is going to allow network devices to learn their time from the network. However, the algorithm that it uses is not as complex as NTP, and therefore it might be a little bit less accurate. And remember, a few moments ago, I mentioned that POP3 is a way that we could retrieve email from a server. And I mentioned that it's not really recommended today if you have the option of using IMAP4 instead. With IMAP4, we still can retrieve email from an email server, but depending on how you have things set up, that mail is not necessarily removed from that server. What many people do and what I do is I create a series of folders on the email server. And as I'm reading through my email, if I don't need it, I can delete it. But if I want to keep it, I can just move it to a folder, and the folder lives on the email server. And that means that I can check it from my smartphone, from my laptop, from my desktop computer, and it's still there. It didn't get removed from the server the first time I checked it, which probably would have happened if I had used POP3 instead. Next on our list is LDAP, Lightweight Directory Access Protocol at TCP port 389. This can allow organizations to have one repository for username and password information and information about that user, like their email address, their phone number, and we can have multiple servers and services on the network that reference that LDAP database instead of trying to maintain their own database. Imagine if your email system had its own database of users and passwords, and each file server had its own username and password database, and so did your VPN connection, and just on and on and on. Imagine if each of these network services had their own username and password database. If you changed your password on one, it would not be changed on the other. That does not scale very well. With LDAP, we can have multiple servers and multiple services pointing back to this single repository of user information. And we mentioned when we're surfing the web, we commonly use TCP port 80. That's HTTP. However, if you're connecting to a site where maybe you're doing a credit card transaction, you're checking your bank statement, you're buying a book from Amazon.com, you're probably going to be using HTTPS, Hypertext Transfer Protocol Secure. That's a way for us to encrypt messages going between our machine and the destination web server. That uses TCP port 443. A popular protocol in the Unix world is RSH, or Remote Shell. That allows us to be sitting maybe on one Unix host, and we can execute a command on another Unix host. We're a remote user, but we could still execute a command on that remote host. Next on the list is Real-Time Streaming Protocol, RTSP. This might be used when you're watching video from a video server, and this protocol allows us to control the playback of the video coming from that server. And I wanted to include another protocol on this list that was not considered a well-known protocol. In other words, its port number is not 1023 or less. And I wanted to include it to make this point. Just because a port number is not 1023 or less, that does not necessarily mean that it's not recognized industry-wide. For example, RDP, Remote Desktop Protocol. That's a Microsoft protocol that can allow us to view and control a Microsoft Windows computer, as an example, from another computer. And it uses TCP port 3389. Not technically a well-known port, but it sort of is well-known because multiple vendors out there have recognized that this is the port number that Microsoft is using for remote desktop access, and they might implement that into their software. So just because a port number is greater than 1023 does not mean it's not recognized industry-wide.